In this video, we're going to talk about how to generate a software bill of materials with Syft and Jenkins. A software bill of materials is not just a list of the different components in a piece of software, but it can also be used to protect organizations from using software that could be harmful to them. Syft is an open source project from Anchor that can be integrated with Jenkins to generate a software bill of materials. We can then use the results from Syft to determine if any of the software within our application could be harmful to us or not. Here's our starting point for today. We have a Jenkins LTS controller version 2.303.1. When it was installed using install suggested plugins. Attached to this controller, I have an agent connected, and on this agent, I have three pieces of software. I have Docker, I have JQ, and I have the Syft binary. Down in the description of this video, there is a link to a gist that has all of the links that we're going to be looking at today, along with any of the pertinent commands that you may need. Now, what I've done here is I've gone ahead and SSH'd into my agent. Let's take a look at what Syft provides for us. So we're going to type Syft --help, whoops, too many, and then let's just pipe that to more so it doesn't just go flying by. And we can see here that Syft is used to generate a package-based software bill of materials from container images and file systems. And you can see different ways to call this. Syft packages, and you give it an image name. You can pass in output formats, in this case JSON or CycloneDX or SPDX. You can also make it more verbose. All of these different options are available to you. Now, also, you can supply your own image sources, whether or not that's your repository coming from your registry, or maybe you're just looking at a file system, like what we're going to be seeing in just a few moments. Now, you can also specify different schemes, meaning I can look at Docker Archive or OCI Archive or dir. So you can be very specific in how you want Syft to run against whatever your target may be. For our sample application today, I've forked Spring-Pet Clinic, and that's what we're going to be working on. And in fact, we're working on a branch called Syft. This repository is public, so you can follow along and test this out in your own environment. Now you'll see here that we have a Docker file that's been added that wasn't there from the upstream Spring-Pet Clinic. And I've added in 3 Jenkins files, 1 for source and 2 for containers. We'll work our way through each of these as we move through the rest of this video. So let's take a look first at our Jenkins file source. What we're going to be doing is we're going to be doing just a Maven W clean package, and we're skipping check style because we don't care about check style in our current run today. In real life, you would care. And then we're going to generate our software bill of materials, or our SBOM or SBOM, however you want to refer to it. And I'm calling Syft packages dir::. So generate a list based on the root of my project. So let's go back over to our controller and let's create a new job. I'm going to call it Syft, the pipeline, and OK. So we'll go ahead and change this to pipeline script from SCM, change this to Git, set our repository URL. I'm going to change our branch to Syft, and change our script path to Jenkins file -source. Let's just make sure that is correct, and it is. Okay, good. And click on Save. And let's click on Build Now. And we'll fast forward through the rest of this job run, and then we'll come back in and take a look at what the output is for Syft. Now that the job has completed, let's take a look at the output of Syft. What we see here by default is a table that gives us 3 columns: name, version, and type. For the type, we see Java Archive for every one of these items. Now that sort of makes sense because we're analyzing a directory, and every one of these items that are here are jar files. And we can see here that all of the versions that are here are just what they happen to be based on our POM XML. And also based on whatever the Spring Boot framework needs for those versions. So we've taken a look at our software bill of materials, generated by Syft, looking just at the directory. But the plan is to take all of our application here and bundle it into a container image, so our final deliverable isn't just going to be a WAR file or just a zip file, but instead is going to be a container image. So what we need to do now is we need to modify our job to go ahead and build our container image based on our Docker file. So let's go back over and take a look at our Docker file first, just so you can see it. So we're building it based on OpenJDK 16 Alpine and just a handful of commands inside of our Docker file. Now, let's take a look at our Jenkins file, container1. This is going to be the first one that we're going to run. So the first thing I'm going to do, just for cleanup and for the purposes of this demonstration, is I want to completely remove Java Docker latest, because that is the tag that we're actually going to build. So I'm just cleaning up, we're going to create it, and then we will run our analysis using Syft. So now let's go back over to our job, and let's change our configuration, and instead of calling source, we're going to call container-1 and click Save. And let's click Build Now. And this is going to take a little bit longer, but we're going to compress the time so you can see what comes out in the end. Now that the job has completed, let's scroll up and see what changes we see here as compared to what we saw when we just ran our Jenkins file -source. Now, one of the first things you may see here is we see APK in the type along with Java archive. Remember that this is an Alpine-based image, so APK sort of makes sense. There's another one that's got SSL client. And also notice that this is a lot longer this time. This has not just the files that we needed for our application, but also all of the files being carried along from the packaging part of our application. So we keep scrolling up, and we see lots and lots of items. Now, you might be thinking to yourself, okay, this is interesting, but what does this really mean to me? Now we can see here that there are a lot of Java archives listed as the type that we probably do not want packaged inside of our container image. Let's make up an example right now. Let's imagine for a moment that we do not want Ant inside of our container image. So what we want to do is we want to modify our job to check to see if Ant exists in the output of Syft. Now we could take this output, pipe it out to a file, and then just go ahead and scrape through this table format. However, Syft gives us the opportunity to use different output formats. And the type of format that we're going to use in our case is just JSON. So let's take a look at our Jenkins file that we're going to be using for our checks. And in this case, we'll go back over to Jenkins file container-2. So this looks similar to the -1 with a couple of extras. In my sort of warm-up step, I'm removing the container image, java-docker:\latest, but I'm also removing a java docker sbom.json file. If you look a little bit further, you'll see why, because we're actually creating that file at line 19. So ignoring this, we create a container image, we run our packages, but then we specify an output format of JSON, so -o JSON, and then we're redirecting that out to this file, java docker sbom.json. And then in our example, we're just saying, hey, can I find Ant in this output? And I'm going to cat out my JSON file. I'm using JQ, and I'm going through the output, looking inside of artifacts, and I'm selecting where the name equals Ant. And if I find Ant, that's actually a success from all of this piping, then what that means to me is that's actually an error because I found Ant. I don't want to find Ant. So I'm going to force an error and fail our pipeline as it runs. So let's go back over to our job and make one final change. We'll click on Configure. We'll change container1 to container2. We'll click Save, and we'll click on Build Now, and then we'll look at the output once it completes. And we can see from this output, now that it's completed, that we were able to run our Syft against our image that we just created. We output it to JSON, and then we run through the steps. Does ant exist? So we do our cat of our JSON file, and then we're JQing that file, or the JQing the pipe from this output. And we can see from the output of JQ that it did find name equals ant, which then rendered out for us here. So since that was found, we're actually skipping finally done, because maybe in finally done we're going to go ahead and push that image up to our registry. But since we found ant, and that was our business rule, that if we found ant, we did not want to go ahead and push our image to a registry, then the job failed correctly as we wanted. Why should you create a software bill of materials for your application? A software bill of materials is an important artifact for any application. It not only helps to identify the components that were used while you were building your application, but it can also be used to track over time what libraries and components are bundled. Also, a software bill of materials helps build trust with users of your application by demonstrating how the application is built, and it also communicates compliance efforts. If you have any questions or comments, you can reach out to us on Twitter @CloudBeesDevs. If this video was helpful to you, give us a thumbs up. And if you haven't subscribed to CloudBees TV yet, why not? Take a moment, click on that subscribe button, and then ring that bell, and you'll be notified anytime there's new content available on CloudBees TV. Thanks for watching, and we will see you in the next video.